Hello, I do believe it's live. Well, this is perhaps overdue. Now, my interaction with Inmendham on physics uh, has a long history. Uh, the first time Inmendham ever blocked me, years and years ago now, I mean, closer to a decade than to a year by far. So, was because he was describing the speed of light in a totally wrong way, as if something's relative speed could be more than the speed of light. And so he blocked me. Now he unblocked me, and over time he seems to have corrected his mistake about that. But in this new system, I think it's been very difficult for me to find which part of his system is the natural philosophy I'm supposed to be able to engage with. Because physics is a subset, a very refined subset of natural philosophy, came from natural philosophy, where it's very careful about the math and the style of the claims that are made. You can have natural philosophy that argues with the interpretations made in physics, expands on them, fills in the blanks, talks about sort of metalogical levels where that explain the things that explain that are the reason we believe in physics or whatever. You know, you can have a philosophy of science, you can have a natural philosophy that adds on or supplements science, and you can have one that differs with science in that it can differ with the interpretations they teach you, right? Like in quantum mechanics, the Copenhagen interpretation, it's actually, in dispute among physicists, and even if it wasn't, over time through multiple generations, it would inevitably be bound to be, and anybody can take part in that. But it's hard to figure out where Gary's, you know, what he's trying to get at. So I read these pages of his, and the whole claim that his system is somehow Newtonian to me is like, that I don't get at all. To me, it's like an alternate quantum physics. It's weird in its own right. It's nothing like Newtonian atoms. I mean, there was hope that a little tiny atom of gold was basically just, the smallest piece of gold. And it looked like, if you could look at it, it would look like a little tiny piece of gold. But anyway, whatever. All right, so I was thinking of reading this whole thing, and I can do that, but let's jump down to a bulleted list here, just to start off, because, oh, and by the way, I have disagreements, or rather errors I could point out also in Hythlodae's responses, which to me is interesting that they both are antipodally mistaken in different ways. But Gary's are much, much more severe. And in fact, Hythlodae's might just be a matter of semantics. When you're answering one person's argument, Gary's, you might make a statement in the context of that sounds wrong in a, out of context. And I certainly have not been able or wanted or whatever the word would be to watch all of Gary's videos that Hythlodae happens to be responding to, whereas Hythlodae makes videos at a rate, and my appreciation of him is such, slash whichever, and both, half of one, dozen of the other. I do watch his videos. On the other hand, I've watched many of Gary's science videos, including in this new series in theory, and talked to him live about it, and found it incomprehensible, basically. So this written version does help me comprehend it, but that simply means that the errors are, apparent. We'll see if we can discuss these, and adjustments could be made. Again, some of it could be semantic, could be rhetorical, could be in the definitions of the words that we use. things like his total misapprehension of what I would consider polarity, what polarity really is. It's hard to tell how much of it is a misunderstanding of the phenomena that we already call polarity, and he's just appropriating a word, or how much, well, I guess that's basically both sides of it. I mean, how much is he misunderstanding the phenomena that we call polarity already, versus how much is he just taking the term to describe some sort of shape concept in his extremely abstract physical model. Now, here, what I wanted to start with is, he says, let's list what we really know to be true about photons. Okay, a list of 5 things. Let's see if any of them are actually true. First of all, they generally move from point A to point B in a straight line. No. It's already easily demonstrated that light is curved, excuse me, curved by when it's in a gravitational field. Or another way of putting that, according to Einstein, would be that light is curved when the observer is in an accelerated frame. So that's something to think about. If I'm in an inertial frame, light goes in a seems to go in a straight line, unless it travels through a non-inertial frame, right? Okay, but of course, every bit of mass in the universe creates a non-inertial frame, an accelerated frame, equivalent to an accelerated frame. So in reality, photons are curving through this. But let's say in space, far enough away, R squared law, etc., it's going straight enough. Whether it seems to be straight can have to do whether you yourself are in an inertial frame or not. So you could say, in some sense, as we do say, that light tends to travel in a straight line, but in reality it does not travel in a straight line, because when it goes through these gravitational fields, so-called, these are non-inertial frames, and the light curves. This is true. Elsewhere in this paper, he talks about the electromagnetic nature of light, and doesn't seem to understand that you can calculate this speed based on the laws of the magnetic and the measured behavior of the electric and magnetic fields and the way they interact with each other, and how fast they do that interaction and whatnot, and you'll get the speed of light through that calculation. As a matter of fact, the speed of light was both measured and calculated several different ways in different investigations, not necessarily thought to be related at the time, and the speed came out the same. That's one of the things that was like a revelation. So one of them's true, one's false so far, 50-50 so far. They have a shape expressed as polarization. The polarization is meant to be an orientation. Now, is that what you mean by shape? Who could know, right? But let me put it this way, because this is the simplest way to understand, in a physical, geometric sense, the polarization of light. I'm quite sure of that. Now, this example, this example is the most straightforward geometric understanding of the polarization of light. When you have a radio antenna, right? Polarization of photons, let's say. When you have a radio antenna, a wire, basically a spike, hard wire, a pole, straight up and down. What's going on there, how you create radio waves, is you have a magnet at the bottom, an electromagnet that you can turn on and off. When you turn it on, the electrons in that pole, you know, shoot down. And if you reverse it, they shoot up. You turn it off, stop moving, right? So by moving those up and down in the pull, you're wiggling them, and they are in an electromagnetic field, right? And the magnetic field vector, if you could, with your fingers, pull at a certain point the magnetic field up, which you can't actually do by inducing a magnet, but let's say you could pick it with your fingers and pull it up, what would happen is you'd also be pulling up at a right angle at the electric field. And these two fields interact, and when you let go, it would shoot down like a rubber band, and both of them would shoot down, and then they'd shoot out the opposite way, and they would oscillate back and forth like that and shoot forward in a direction. And that's what a photon is. So when you wiggle the electrons up and down, you're creating ripples in the electromagnetic field. And the photons shoot out in a circle, just like a water ripple, away from the antenna, right? And the polarization of the photons is the up and down of the antenna, right? A polarized filter oriented in the same or 90 degrees of the direction of that antenna's up and down direction will match geometrically in our real space between the direction of the polarization filter that happens to be on whatever the detector filter that is detecting the polarized light. And these would be, of course, radio photons. Now, what's so-called random about this situation is which direction do the photons go, right? If you're looking down on the antenna is a dot in the middle of a circle looking down, and the ripples are going out in a circle, but the photons are particles. Which direction on that circle of that 360 degrees do the photons take? And that's allegedly random. That's equally distributed. Could be in any of those directions, right? So if probabilism is when, hey, we don't know what's going to happen, but the number 7 is going to come up more than the number 12 with these dice, and something random, properly random, would be, equal chance of all of the things. Which direction of the 360 degrees each individual photon comes out, unknown. If you make the power so low on that antenna, broadcast antenna, that only one photon comes out of the antenna at a time, you won't be able to predict which direction it's going to go, or control which direction it's going to go. Right? That's theoretically a fundamental principle. Maybe there's a way to do it anyway, but the tricks that we know to cause that are more like the way we make a laser. I mean, you basically just don't let the photons that don't cooperate out of the laser. You end up with a bunch of lasers, a bunch of photons shooting in the same direction and in phase, and you got a laser. So generally, polarization is this kind of thing of like, well, if a photon's coming at you, pretend it's going up and down. Right now, it's not. It's staying in its point of space, its line, but the magnetic field and electric fields can be visualized as, vectors at that point. And so this plus shape where the magnetic field is going up and down and electric is going, and they're all the perfect time, so they go through the 0 point at the same time, and this little plus is shooting at you. If the photon's coming to your eye, this little plus is shooting at you. In the middle is the photon, the point itself, and then the magnetic and electric fields oscillating around that point, right? Oscillating around that point, if you can imagine the sine waves and 2 dimensions doing that from coming straight at you, it's oscillating in this little plus, and the angle, the rotation of that plus, that's the polarization, not the shape. Okay. They are identifiable by a carried frequency. I don't think so. So I don't know what carried frequency is, but let's say they have a frequency. A photon has a frequency, right? We know that if you burn copper, you get this green photon, for example, this really beautiful green and blue greens mixed, but it's two photons mixed together. But you get this green, among other things, I guess is what I'm saying. However, whether that is real, it's not a green photon for everybody. It's a green photon for observers or phenomena that are in the same rest frame as the emitter. If you are on another planet or galaxy that's traveling towards something at a quarter of the speed of light, that photon would no longer be a green photon. It'd be another color, or maybe one of the invisible colors, so to speak, of other parts of the spectrum, ultraviolets and your infrared. So I don't think you can say they're identifiable because the wavelength of that photon, and this is a proved thing, I claim, easily testable, really, in the labs and in our experiences, uh, it's easy to look close at the universe these days. You cannot identify them that way. Things have blue and red shift. And so what frequency they carry and even what amount of energy is relative to whoever absorbs that energy. Now, this, again, totally wrong. No, look, when emitted from a spherical source, they dissipate at the same rate as gravity and magnetism, obeying the inverse square rule. Yeah, no, photons, you said photons. Look, the force of gravity and blah, 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 and the intensity of light, they dissipate by this R squared law. And what it is basically is if you have a spherical bubble that is expanding around a point, right? A ripple, a 3D ripple, an explosion underwater where the wave is hard to see. It's easier to see on the surface, right? But there's a compression wave traveling out in a circle, right? Now, the the sort of the tectonic shock that bubble has as it passes by you dissipates as the bubble gets bigger because the bubble's getting thinner, right? The bubble is getting thinner. And that's what happens as far as we know in gravity and magnetism, or any field, any idealized medium. The thing about photons is that they act like a 3D ripple, and the intensity of the photons indeed does dissipate. But an individual photon doesn't dissipate at all. It's permanent. I think Gary knows this, actually, if he's thinking about it. The photon stays the same until it runs into something. The reason it dissipates anyway, apparently, is a statistical phenomena over all the billions of photons being put off of this sort. So let's say I have an antenna with a little ball, and the ball is actually the only antenna. So it's going off in a circle. It's shooting off billions and trillions of photons in all of these random directions. And but the directions are always perpendicular to the surface of that little ball, right? So they are going out at angles to each other, and the speed at which those angles diverge means that to get the same number of photons, you got to have a bigger area. So it still dissipates, right? So what's dissipating is the number of photons per square meter, right? Not so that's totally a geometric thing, and it's actually mathematically the same explanation mathematically of why gravity and magnetism dissipate. And in fact, it's pretty easy to see that in a three-dimensional space, if you have a three-dimensional phenomenon right? It's a three-dimensional phenomena of emission from a point source or something close enough to a point source. Uh, you're creating a two-dimensional surface, right? Two-dimensional surface. The surface of a bubble, a soap bubble or something, is a two-dimensional surface, right? It's a two-dimensional surface on that surface, right? On the surface of the bubble, it's a two-dimensional surface, right? And the radius is a one-dimensional surface, right? So the radius is the distance of that, the current point of the surface of the bubble from the point of origin. And that radius gets bigger. It's a one-dimensional thing. It gets bigger, and the amount, squared in the surface, the two-dimensional surface, is going by that r squared, right? So that's why you have the r squared rule of dissipation, because it's dissipating as the surface gets thinner of this bubble as it gets further and further away. Yeah, this is, so I don't even know, how long has this already been? Let's see. So it's already 21 minutes. So I guess if I go through other stuff, because there was just so many mistakes in here. And then there's this other one about the two slit experiment. I guess I'll comment on this real quick before I finish this one. But okay, it should be a known fact to all college educated physicists that there is a single slit interference pattern that is identical to the two slit pattern, with the exception that the central maxima produced is twice the width and 4 times the intensity. That's entirely false. The interference pattern, Gary, is two, right? Two diffraction patterns. So when you put light or any wave through one slit, the way it spreads out, okay, that's diffraction, right? And if you put white light through something like that, or, just like really noisy water with all of the frequencies in it, you would get a rainbow, right? Because different wavelengths of light get spread out to a different amount by a slit of a particular wavelength, right? If you really want to spread light out, then the slit would be the width of the wave, or a perfect multiple, but ideally the width of the wavelength. That would spread that light out more. So other wavelengths not close to that would be spread out less, and you get a divergence and the prism effect. You get a rainbow, right? That's the diffraction pattern. And if it's a laser with just one color of light, you get the diffraction pattern. The banding happens, and it spreads out. The light spreads out from the slit, and there's a banding kind of a pattern because of how that works. Okay? And the math is very accurate and predates quantum mechanics. It's part of wave mechanics, like people studying fluid dynamics came up with. The two slit pattern is two of those diffraction patterns overlapped, right? It's two diffraction patterns overlapped. And the important part is that it's not two as if you superimposed one taken at one time over one taken at another time. No, the parts where one diffraction pattern has a high point in the wave, and the other diffraction pattern has a low point in the wave, they cancel out to zero, right? It's not just the light of the bright one there, they cancel out to zero. So the interference pattern is the fact that there's two diffraction patterns in time and space at the same location of activity that interact that way. Even though you send one photon through at a time, there's this pattern of two diffraction patterns, one from each slit. And if you do 3 or 4 of the rest, then you have the interaction 3 or 4 in the rest. Right? The point is that the diffraction patterns are not only overlapped on the detector screen, but they're interacting in real time, even if you send one photon through or one electron or one of whatever through at a time. You also say here that the fact that this result is not in any way duplicated in fluid wave mechanics is good reason to think the two slit results are just coincidental. They are. The overlap of two diffraction patterns from waves, well understood by wave mechanics. Essentially, the mathematics of inventing the concept of trigonometry, sine and cosine, turning the circle into a two functions basically that interact, and looking at the cycles and the frequencies that working with sine or cosine waves create. You could calculate what you expect, well, and also from just the wave mechanics of how diffraction works. Between those two things, the math and the observation, you can see what two, water, if it goes through a slit, is diffracted. And you can do this in 3D. It's just hard to see with your eyes. But you can do this in water waves underneath the surface go in 3D. When we're looking at the surface, we're seeing a cross section of a 3D wave, right? And in fact, two overlapping diffraction patterns in water waves with two slits creates a pattern that matches what you expect. You're being ignorant to look at these patterns of a single slit and of two slits and say, look, they're the same. They're not the same. If you look at them closely enough, you will see there are fingerprint differences between the two of them. And you obviously have not done that, or you blocked out your vision when you thought you were doing it, because the result of overlapping diffraction patterns and the interference pattern that results, where the two diffraction patterns interfere, is a feature of all wave mechanics, any medium, any wave, water or otherwise. Okay. It makes no sense at all. There's also the problem that single slit interference makes. Look, there is no single slit interference, Gary. That's called diffraction. There's a fact when a wave hits a barrier, with like a slit, or if it was water, you could have a seawall with a opening in it. When the water goes through there, it doesn't just get off and make a straight thing. It makes a little cone. And the angle of how big of a cone it is, how wide of a cone it is, depends on the wavelength of the water and the width of the slit. And that's not an interference pattern. We call that a diffraction pattern. And the interference pattern is when you have two such openings, the two diffraction patterns overlap. They interfere with each other. And that is what we call interference. So the two slit has interference, the one slit has diffraction. The two slit has twice as much diffraction, but what's interesting is that it interferes. Why is that interesting? Because in the two-slit experiment, you can slow down the photons if you want so that only one Geiger counter click is happening at a time. Click, photon, click, photon, click, photon. And why the fuck do you still see an interference pattern of two overlapping diffraction patterns when one particle was going through one slit at a time and making one dot of light on the detector at a time? You can watch the detector dink, dink, where the single particle photon goes. That gives reality the single particle photon. But how an interference pattern shows up, that's not explained. And your idea that it's the same, the diffraction, you think we haven't fucking noticed that? That's not even a high science thing. In my undergraduate physics, I've done the math. The interference pattern of two overlapping diffraction patterns interfering with each other is different from one diffraction pattern just being itself. It's so beyond controversial. It's, if you cannot accept that, there's no way to take you seriously, because it's clear you just don't understand the concept. And it is understandable. You don't have to be a educated physicist. This is something that a natural philosopher could make sense of, even with their common sense, without doing all of the math. It's one diffraction pattern. The interference is when there's two of them, and the importance of that is only important because how can you have interference between patterns masked out by two slits when there's one photon going through one or the other of the slits at any given moment? That's the part that's like, what? Right? Which you do not explain. None of this theory of yours seems to address that. You're in denial from the beginning. Then you go off on how it really is without ever addressing. Your system is not going to deal with the reality you have already denied. All right, cheers, everybody. And if you think I should go into this shit more, or if you would like to hear about Hythlodae's mistakes, please leave comments, leave links to the videos you would like me to comment on, because I peruse these. But, they're all out there. I can't keep up with all of it. But, I think some physical education might be in order, especially for Inmendham. But yeah, I think I have a lot of, the least of it is Hythlodae's cavalier about, assuming determinism, because old Gary agrees, so he's arguing with Gary, so he gets away with that. There's things like that. But there's also other mistakes and misstatements, in my opinion. If you're interested in that, leave a comment. If you're interested in me, for example, I'm glad the way I went through this. It's been a long time so far, so I'm not going to keep going. But I did have the intention. I could still read this through sentence by sentence if we want. On the other hand, I sort of spent the energy that had built up, and I feel like I've addressed it sufficiently. So feedback is appropriate in this particular case. All right, having said that, I will quickly bid you adieu. And from my lofty loft in very northernmost Maine, claim only applies to United States residents, not valid in other continents or even nations if you're Canada.